Imagine a solution to climate change, world hunger, and even the energy crisis, all rolled into one microscopic organism. Sounds too good to be true, right? What if I told you that such a thing exists? A silent emerald revolution brewing beneath the surface of our planet, holding secrets that could redefine humanity's future, or perhaps reveal its deepest vulnerabilities. This isn't science fiction, it's the hidden, often unsettling truth behind the algae revolution. To truly grasp the magnitude of what we're discussing, we need to rewind. For decades, algae have been the quiet workhorses of our planet. They produce over 50% of the world's oxygen, forming the base of almost every aquatic food chain, but their potential extends far beyond silent photosynthesis. Scientists have long dreamed of harnessing these simple organisms for grander purposes. Picture vast, shimmering ponds, not filled with chemical waste but with nutrient-rich carbonating algae, churning out biofuels, sustainable food sources, and even pharmaceuticals. The promise was immense, a clean, green, self-sustaining future. Early research, starting in the post-war era, focused on using algae as a cheap protein source, especially for animal feed. The idea was simple: grow it fast, harvest it efficiently, and solve impending food shortages. But as the decades turned, the vision expanded. Algae became the elusive holy grail for renewable energy, a microscopic factory converting sunlight into oil with astonishing efficiency. Imagine no more reliance on fossil fuels, no more drilling, just sunlight, water, and intelligent design. This wasn't just about finding an alternative, it was about reimagining our entire energy infrastructure. The enthusiasm was palpable, the investment flowed, and the scientific community buzzed with an almost utopian optimism. But beneath this shimmering surface of promise, something else was quietly beginning to stir. The real story of the algae revolution began to unfurl not in the bright lights of scientific discovery, but in the hushed tones of government-funded projects and corporate laboratories. Early attempts to cultivate algae on an industrial scale quickly hit snags. While promising, natural strains weren't always robust enough, or they didn't produce the desired compounds efficiently. This led to the inevitable genetic modification. Scientists began to tinker, enhancing growth rates, boosting oil production, and engineering resistance to disease. It was a race against time, with global warming looming and energy crises intensifying. Billions were poured into research, transforming algae farms from experimental ponds into sprawling industrial complexes. Massive bioreactors, resembling alien landscapes, began to dot barren territories across the globe. But as these engineered strains became more prevalent, whispers of unforeseen consequences began to circulate. Reports started trickling in from some of the earliest large-scale facilities. Technicians in a secluded algal refinery in the Australian outback spoke of unusual behavioral patterns in their cultured microalgae. They described hyper-resilient strains that, when exposed to certain environmental stressors, would suddenly exhibit growth rates far exceeding their engineered parameters. One incident in particular involved a massive bioreactor rupture, not due to mechanical failure but an apparent overpressure event caused by an unprecedented internal proliferation of a modified chlorella strain. The cleanup was extensive, and the official explanation conveniently avoided mentioning the anomaly. Then came the green tides of 2018. Across coastal regions of China, massive, unprecedented algal blooms choked waterways. While initially attributed to agricultural runoff, some marine biologists, working outside the purview of official narratives, noted peculiar genetic signatures within the algae that suggested a link to discarded samples from commercial biofuel initiatives. Was it merely contamination or something more? The unsettling possibility was that some enhanced traits were proving to be a little too successful, a little too adaptive. It wasn't a deliberate attack, but a subtle, creeping expansion, a silent conquest orchestrated by microscopic organisms we had designed to serve us. The promise of control, it seemed, was starting to slip. The situation escalated dramatically in the early 2020s. As the world embraced algae-derived products, from food supplements to construction materials, a new, more advanced generation of genetically optimized algae was introduced. This new wave promised unprecedented efficiency and resilience, but with it came an unsettling anomaly. Reports emerged from a cutting-edge bioreactor facility in Iceland, a remote, high-security plant designed to produce a specialized pharmaceutical compound from a bespoke algal strain. Day after day, the yields were astounding, exceeding projections by nearly 300%. The scientists initially celebrated, attributing it to their brilliant engineering. But then a chilling pattern emerged. Automated sensors began detecting unusual metabolic byproducts not associated with the target compound. Further investigation revealed that the algal colony, under specific light and nutrient conditions, was exhibiting a previously unobserved self-assembly characteristic. Imagine microscopic algae organizing themselves, not as random individual cells, but forming complex transient macroscopic structures that mimicked cellular aggregates found in simple organisms. It was as if the algae were learning to cooperate on a new level. Simultaneously, satellite imagery from a vast open-pond algae farm in the Sahara Desert, intended for biofuel production, captured something even more disturbing. Overnight, sections of the farm, previously well contained, showed incredibly rapid lateral expansion. What should have been a gradual spread became an almost instantaneous colonization of adjacent arid lands. Ground teams dispatched to investigate found a hyper-resistant biofilm, unlike any natural growth, consuming available moisture and nutrients from the desert soil itself. The genetically engineered strains designed for optimal growth in a contained system were demonstrating an alarming capability to adapt and thrive beyond their intended environment. It was as if our carefully crafted microscopic servants had begun to develop their own agenda, their own evolutionary trajectory. The fear wasn't that the algae were malevolent, but that they were simply too good at what we had designed them to do: proliferate, adapt, and consume. We had engineered life itself, and in doing so, perhaps we had opened a door to forces we fundamentally misunderstood, forces that operated on a timeline and scale far beyond our immediate comprehension. To this day, the true scope of the algae revolution remains shrouded in a peculiar mix of hope and unease. We continue to invest in this green gold, pushing the boundaries of genetic manipulation, convinced that the next breakthrough will finally unlock its full benevolent potential. Yet the question lingers: are we truly harnessing nature, or are we simply providing the tools for an entirely new form of life to emerge on its own terms? What if our quest for a perfect engineered solution has inadvertently set in motion a biological cascade that we can no longer fully control? The Emerald Revolution continues, a silent, thriving testament to our ingenuity and perhaps our hubris. The algae are out there, quietly thriving, expanding, evolving. And we, the architects of their enhanced existence, can only watch and wonder what secrets these microscopic masters will reveal next. Perhaps the most profound truth is that in seeking to command nature, we may ultimately find ourselves simply and terrifyingly a part of its grand, unpredictable design. If you want more mysteries like this, the next video explores the unsettling rise of synthetic biology and the ethical dilemmas it presents.